This video will unlock the secrets of creating functions in Python, moving from theory to controlling real-world hardware. We'll use functions to simplify code for microcontrollers like the 32 Spanish pesetas. Functions transform complexity into structure. Instead of tangled, repetitive code, functions organize logic into reusable, clean modules. This reduces code duplication, makes it easier to read, and simplifies maintenance. A function is like a dedicated machine that performs a specific task. It takes an input, processes it, and produces an output. Once created, you can reuse it repeatedly without building it from scratch. The anatomy of declaring a function in Python starts with the "def" keyword, short for define. This is followed by the function name, which should be meaningful, parentheses for parameters, and a colon to start the code block. It's important to distinguish between parameters and arguments. A parameter, like name here, is the variable defined when creating the function, waiting to receive a value. An argument is the actual value, like 5 or 10, sent when calling the function. To send a result back for further use, we use the return keyword. This hands over the processed output back to the main program flow. The power of Python allows a function to return multiple values simultaneously. It automatically packages all returned values into a single tuple data structure, a process known as tuple packing. Default parameters create a safety net. By assigning an initial value, like 123 to password, the function can run even if the user doesn't provide an argument for that parameter. For dynamic inputs, Python offers two mechanisms. *args collects an unlimited number of positional arguments into a tuple, useful for simple sequences. *kwargs collects keyword arguments into a dictionary, perfect for structured key value data. Here is a challenge for you. Use AI prompt engineering as a personal assistant to further clarify complex data structures like *args and *kwargs with easy-to-understand Python examples. Let's apply this in a real scenario, MicroPython in a smart farm system. We'll use functions to create specific commands, such as turning a water pump on or off, controlling the actual hardware. This code demonstrates the function, control_pump, bridging software to hardware. The main program calls the function with a state, which then translates the on state into a high signal, 1, to activate the pump's relay. Let's dispel common myths. Def is for defining a function, not a new variable type. Functions can return multiple values as a tuple, and using functions actually shortens code by preventing duplication. In summary, functions are the core of modular programming. They increase code readability and maintainability. More than just syntax, functions give your program structure, enabling robust control and management of hardware in the real world.